Imagine chopping off your hand and watching it grow back in a few weeks. Not just a scar, but bone, nerves, and skin, perfectly reformed. It sounds like science fiction, but for the axolotl, a Mexican salamander, this is reality. Humans, the dominant species on Earth, lost this ability. Instead, we heal by permanent scarring. Why did we lose this superpower? Because for humans, injury triggers emergency mode. Our priority is to stop bleeding and prevent infection immediately. Fibroblasts rush to the wound to seal it with collagen, a functional but messy biological duct tape. We chose speed over perfection. The axolotl doesn't patch. It performs biological time travel through a process called dedifferentiation. Its specialized bone and skin cells undergo an identity erasure, forgetting their roles to become pure potential once again. At the wound site, these cells form a blastema, a cluster of raw cells that acts like biological Play-Doh. This structure functions as a living 3D printer nozzle, reading the genetic blueprint to rebuild the missing limb precisely from scratch. So why don't we do the same? Evolution is about trade-offs. Regrowing a limb is energy expensive, requiring massive caloric resources that our ancestors couldn't spare. For humans, survival of the fastest meant scarring allowed us to flee predators immediately instead of waiting months for a new leg. But there is a deeper reason. The cancer shield. The rapid cell multiplication needed for regeneration is biologically similar to how tumors grow. Humans likely block this ability to lower the risk of cancer. We traded our limbs for longevity. Yet, the blueprint isn't completely gone. Remnants of this ability still exist in human livers and even in children's fingertips. Today, scientists are trying to toggle these genetic switches to awaken our dormant blueprint and enable scar-free healing. The superpower is still inside us. We just need to learn how to turn it back on.